Hello, I am Gordon Piltz, and this is my experiment on the properties of two different types of tape. For this experiment, I would pull on two different types of tape to measure their elongation and the force required to elongate them that distance, and I would use this and the relationship between stress and strain to determine the Young's modulus and the ultimate strength of the materials. And my procedure was designed to limit my uncertainty and error propagation throughout this lab. And using this lab quest you can see above, I would connect it to this dual force sensor and attach the carabiner right below it to a strip of tape, and I would measure its length from the carabiner into the clamp and pull on the tape until it snaps. The clamp was used in order to prevent the tape's adhesive uh, uh, from detaching from the material, and to ensure that I am truly just measuring the ultimate strength of the material. And I measured the height, width, and length of this strip in order to determine the cross-sectional area, which would be used to calculate the force or the stress in the material from the force applied that I was reading off this force sensor. And I would just pull on the clamp and the force sensor to determine this force from the graph and use the maximum stress or the maximum force through it and a camera to determine the elongation right as the tape snaps. In order to limit uncertainty in ultimate strength, this clamp was used, and in error propagation. And in the Young's modulus, there were a couple techniques used to limit uncertainty. Most notably, I would adhere a small portion of the tape to the surface so that the tape's adhesive would release before the ultimate strength of the material was reached. And this is some photos of my procedure, where you can see the masking tape on the right there, and that Sharpie line was just used to make a common measuring point for the elongation. And I would just use this camera and in a view exactly like this as I pulled the tape. And in the bottom part of that photo, you can see little marking on the ruler there that denoted how far from the tape was adhered to. And I used a set length so that when I pulled on the tape would come off the table before it snapped. And this is to prevent moving into the plastic range or potentially snapping the tape in the test. And I would elongate it about 1 to 2 millimeters and record the force it took to pull it that far. And I did this for a total of 10 trials to determine the Young's modulus, and then I would pull them using a clamp until fracture 10 times to determine their ultimate strength. And throughout the procedure for this experiment, I ran into a couple problems. First, the Scotch tape's adhesive was much stronger than I intended, and this caused the tape to snap rather regularly when I was pulling on it, and I had to adhere only 1 centimeter of it to a table so that it would break off the table before the tape snapped. And that took several trials in order to find just how little tape had to be stuck to the table before it would snap. And for the masking tape, its ultimate strength was much stronger than I could measure using my force sensor, and I had to cut the cross section of the tape in half to limit the area so that I could reach the stress using a force that I could measure on my force sensor. This, however, became an improvement later on through the lab, because I could use the entire width of the masking tape when measuring the modulus of elasticity with no way of ever snapping that. The force sensor maxed out well before the tape would fracture. And in my results, I measured the Young's modulus of masking tape to be 1.294 gigapascals, and its ultimate tensile stress to be 26.3 megapascals. And for the Scotch tape, its Young's modulus was 15.36 gigapascals with an ultimate tensile stress of just under 300 megapascals. And this would mean that the masking tape is much easier to elongate or the Scotch tape is much easier to elongate than the masking tape. You can put a much smaller force into it, and it'll stretch. I got that backwards. The masking tape, you can put a much smaller force into it to elongate it a much longer distance, than Scotch tape, around a 15-to-1 ratio of elongation to force in the tape. And the ultimate tensile strength meant that the masking tape will snap under much smaller conditions than Scotch tape, and this is most notable in just everyday practicality. Masking tape is much weaker than Scotch tape. And for my uncertainty calculations, the uncertainty in a ruler was used as 0.0005 meters, or half a millimeter, and the force sensor was 0.01 newtons. And these were used in the equations for stress and strain to determine the uncertainty in both of those values, and then that uncertainty was used in the equation for modulus of elasticity to determine the uncertainty in my modulus of elasticity.